Hey everybody, today we have a system of equations that's cyclic. Cyclic. Some people may say cyclical, but I'll just call it cyclic. And I think that makes algebra slightly easier. Maybe I'm wrong, but notice how this A kind of cycles down to here and everything just gets replaced. So it's cyclic. I guess it's symmetric too, but it's also cyclic. Now we're supposed to find the product of the variables A, B, and C. These are real values summed with its reciprocal. Okay. Now, of course, this is a standard class of problems where trying to find A, B, and C directly would be difficult, I think. But there's ways to solve this without knowing what A, B, and C actually are. Okay, so we do the very natural thing. We just take the product of these three entities here, equal to 6, 11, and 20. And you'll see that right at the end of this, I wrote down 6 times 11 times 20 just to be, careful. Let's see, what does that equal to? 6 times 120, what is that, 1320? So that's 1320, I believe. Isn't it, folks? Yeah, yep. 6 times 11 is 66 times 2 would be 132 with an extra 0, right? Now, this is nothing fancy other than just brute force multiplication. This is a quadnomial, if that's a word. This is a binomial. If you multiply a quadrinomial with a binomial, you end up with 8 terms. And just as a necessary condition, we can count the terms here. We have 1, 2, 3, 4, 5, 6, 7, 8. So we do need 8. I don't think I made any mistakes when I multiplied all that out. Now, remember that, let's see here. And see how we ended up with AB? ABC and 1 over ABC when we expanded this out. Okay, well, what we can do is take these other terms. Okay, we already know that it's equal to 1320, but we can take these remaining terms right here. But what are these remaining terms, folks? If you take a careful look, it's just the sum of these guys, not the product, it's the sum. If you sum these up, you get precisely this statement right here. You see you have A, B plus C, 1 over C, 1 over A plus 1 over B. That's exactly what happens when you sum these objects up. But you also get, 20 plus 11 is 31. You also get 37 right here. Okay, 37. And so what we end up with is that this is equal to 1320. Minus 37, and the mental math there is not too hard. That would be 1283. 1320 minus 37 is equal to 1283 is what I'm getting mentally here. 1283. And I'm just checking when you sum that, yeah. Okay. So yeah, pretty amazing to me. You get a nice integer value. I think if you try to work this out, you get like these if you try to find A, B, if you try to solve for A, B, and C, you get these very nasty looking nested radical expressions, and it'd be very tough. I guess they would be surds where the negatives would cancel out or something. But in any event, the algebra here worked out very nicely, and I think the cyclical aspect of this made this multiplication end up rather nice. But anyway, let me know if that's not true. I think that adds some, it makes it simpler to actually do the algebraic manipulations. All right. So this is equal to 1283.